Welcome to the CCNA series for CBT Nuggets. In this series, we're going to cover each of the objectives that are defined by Cisco for preparation for the CCNA exam. But you'll also find additional information and illustrations. The reason for this, I believe that these objectives are better understood when you provide supporting information to each of them. This particular nugget is designed to serve as a base. We're going to go over the concept of what a CCNA is and the benefits associated with that certification. And then also we're going to take a look at the hardware involved in preparing this series and also the hardware that you will be responsible for as a CCNA and have a solid understanding of it. Our definition of a CCNA is going to start by breaking out the acronym. And here we see that it stands for Cisco Certified Network Associate. What you got to understand is where the CCNA fits in the overall certification picture within the Cisco world. They have three levels of certification. First, what you're going to have is an associate level. And at this level, you see that we have a CCNA and a CCDA. We have network here, and we have design here. So different paths, if you will, to get up to the top level. The next level that you run into as you obtain the associate level is the professional level. And here again we have the distinction between network and design. And then once we get to the CCIE, they're coupled together and we're at the expert level. And as you can figure, once you're at the expert level, you should know both sides of the house. So each of these are individual certifications. The CCIE is the top. Now for the CCNA, we have one test that we take. That one test lasts 75 minutes long, and it has between 45 and 55 questions that they may give you. Why would I want to put forth the effort and the time associated with gaining that type of certification? Here's some of the benefits. First, peer validation. That is, you getting a good understanding as to where you are within the industry among other people that do the same type of job. And there's two reasons for doing this. First is for personal knowledge. Again, understanding where you're at within the industry so that you can set your path forward on how you're going to progress in your career knowledge. The other is differentiating yourself from the pack for a potential employer. And this is possibly the most important. You've got to understand that as employers are interviewing, they have to have a way to cipher through all of these resumes that they're getting in. And one of the quickest ways is to look through there and highlight individuals that have obtained certain certifications within the industry. Now I can speak to this from personal experience. I did hundreds of interviews for a Fortune 50 company. And the first thing we did is we went through the resumes and we looked for keywords. And for entry-level positions, if CCNA was not on that resume was thrown out. We didn't even progress to the phone interview, which, you know, understanding most times when you're interviewing with a company, it's a phone interview and then an in-house interview. Didn't get any further than reading a portion of that resume and then tossing it out if the certain certification wasn't met. So why would we do that? Because this certification takes a level of experience and knowledge that we want for the job, and this is the best way and the easiest way for us to verify that that does exist within the individual. Another reason to obtain a certification is career advancement. Now we talked up here about sending out your resume and interviewing for a position outside of your company and changing companies from company A to B. But you've also got to remember that there's career advancement that can be considered within your company. A lot of companies are set up with a tiered structure. Let's say tier 1, 2, and 3, where the entry-level tier is here at tier 1. Or, as it may line up with the Cisco certifications, this is your associate certification, so the CCNA, CCNP at layer 2, and then CCIE as the third tier, the top tier. There's a lot of companies within the industry that use exactly this. They use the certification program as it's outlined by Cisco to outline the tiers within their structure or their environment within the company. Now, if you want to progress from one tier to another, one of the requirements would be obtaining a certain certification. So if you want to get into the company at all, you've got to have your CCNA. You want to advance from there, CCNP, and then CCIE. As I had said, many companies adopt this structure. Another structure that you'll see out there commonly is that tier 1 would be an entry-level position but not required to have a CCNA, and then the tiers would progress from there. So you would actually have a 4-tiered program, and this is what we're talking about, career advancement within a company, where you're already in the company but you want to go up to another level, which in most cases will include a raise and usually more responsibility but at the same time better benefits. As you advance in this career field of computer networking, you're going to find something that I think is just very amazing. most people in this career field are not concerned with title or position as much as they are with obtaining knowledge and an understanding of what happens within the environment of computer networking. And that's where you're going to find your biggest payoff for the CCNA, directional study. And what I mean by this, Cisco has already set up their tiers, CCNA, NP, CCIE, and it's similar to a ladder that you're going to climb to get to your final destination of being an expert within that certain area of networking. It's analogous to building a house. If you build the roof of a house first, you can later raise that roof off of the ground, say this is ground, and put it on top of your house as you build the structure. But obviously it's easier to build the foundation, build your structure, and then the roof on top. Now, how this is analogous to what we're studying here, the CCNA, as identified by Cisco, is that foundation. And what they're saying is, if you have a solid understanding of these objectives, you can now build your knowledge or your house of knowledge on that foundation. What you don't want to do is start off somewhere within the middle and then try to backfill, because it's going to give you some confusion and some rework, similar to our analogy here of having to put this roof on the house after it's completed. So far in this nugget, we've defined exactly what a CCNA is, and we've also talked about the benefits associated with becoming a CCNA. What we're going to do now for the rest of this nugget is look at the hardware that we're going to use within this series of developing your knowledge in the CCNA objectives. All right, the way we're going to do that, we're going to look at the 3 layers of the OSI model. I know you're not completely familiar with these as of yet, but just understand for our discussion in hardware, layer 3, or a third layer, which is higher than layer 2 and 1, we're going to have devices there called routers. These are Cisco's layer 3 devices. For layer 2 devices, we're going to have devices here that are known as switches, and those are going to be discussed as well within this series. Another layer 2 device is a bridge. And then within the layer 1 devices, which is a physical layer, this is where we're going to see the cables that are used to physically tie the devices together. So we're going to go over the hardware in these categories and in this order, starting top to bottom. Routers within the Cisco environment are divided into 2 groups, and the 2 groups are known as the high-end routers, which we're going to show here. And those high-end routers are going to include the 12,000 series, the 10,000 series, and the 7,000 series. Understand that the 7,000 series is even further broken out into 7600s, 7500s, 7200s, 7100s, and 7000s. All right, and then the other category we're going to have is known as access products. And these are all other routers that aren't the high-end routers. And these routers are going to include the 2500 series and the 3600 series, both of which we have examples to show you in pictorial view. We'll start with the 3600, and we're going to see that here as I pull up the front of a 3600. Now what you're going to notice is that there's not a whole lot on the front side of this particular type of router, but what is here is very important. We have status indicators here that are going to give you a status, obviously, of what's going on within the router at any given time. We also have console and auxiliary ports. We're going to go into these individually in a future nugget, and it's going to tell you exactly what they do, but once you understand what they do, this is where they are. And then also we have a form of memory that can be inserted here. These cards are MCIA cards, the small credit card looking cards. They contain memory, and the specific memory that they have is called flash memory that you can put into a 3600 router. All right, now let's look at the back side of this same device. This is where we're going to have our options. There's 4 bays, 1, 2, 3, and 4. 3 of these bays have been filled with specific modules. The great thing about the 3600 is these modules are interchangeable. In other words, you can have 3 of this one type of module here, or even 4 all throughout, or you can have them mixed as you see it here. And it doesn't matter which slot they go in. I could have had this module in this slot, the bottom module in the top slot, and so on, okay? So 4 available slots. Any slots that are made for the 3600 can be put in here, and they give you extensions and scalability within the network. Here you're going to see a module with 1, 2, 3, 4 serial ports. That's used so you can use this device as a frame relay switch. You also see another model here that's going to have an Ethernet port and then 2 sub slots, 2 smaller slots within that big slot that can be used for WAN interfaces. So this is a 1E for Ethernet, 2W because both of these slots can be used for WAN connections. That's the W part. And then obviously you see the power here for the power cord that can be plugged in, and then the power switch. The other router type that I have pictures of is the 2500 series routers. I'm going to show you the front first. I have 3 that are stacked up here so that I can show you something. Within series of routers, there can be different types. And in the 2500 series, we have a 2503, the 2509, and the 2514. Can you tell the difference? I didn't think so. Everything is identical when you're looking at the front part of these routers. In fact, you have to look at the back section where we have these same routers stacked up before you can tell the difference. Again, we have the 2503 here. Let me start with that as far as explanation. We're going to start at the left. This is an AUI connection, which is used for Ethernet connections. Again, any terms you're not familiar with yet, that's why we're in this series, and you will be by the end. But I just want to give you an understanding of what kind of hardware we're talking about. We also have serial connections, which are used for wide area networking, where this is used for a local area. You have 2 of those. Then we're going to have a BRI connection used with an ISDN, the console and the auxiliary. It's important to note that these are going to be on every Cisco device that we're going to study here. And the reason is we need console connectivity. It's one way of connecting into the router. And the auxiliary port used for other functions like dial-on-demand routing or even modem connections. Power switch, obviously have to have that, right, to turn the unit on. And then we have the receptacle for the power cable. Going on to the 2509, what we're going to see here is an async port between 1 and 8. And this is where you can plug in an adapter that has 8 connections on the end used for async connections. The AUI, just as we had up here, the 2 serial interfaces, again, just as they were here, console, aux, the power on button, and the cord receptacle. Moving on to the 2514, we have 2 AUIs this time, AUI 0, AUI 1, and we have 2 serials, serial 0, serial 1. Notice the numbering. On Cisco devices, starting at the left, you're going to have the smallest number. Moving on towards the right, they're going to increase as they are like connectors. So AUI, there's 2 of them, 0 and 1. There are 2 serials, so 0 and 1. Then we have the console and aux connectors before and the power on button. For the 2500 series of router, I've also included a picture that's going to show you the insides of that router so you can see the guts of what's going on in there. And here we have it. We see some memory slots here, 3 of which are taken up. We also have a slot here for the PCMCIA flash memory that we spoke of before. And after that, it's pretty simply just a motherboard. The interfaces up here in the front. So you have console and aux here. You have the BRI, because this is the router that had the BRI. 2 serials, and an AUI. And then we have a power supply and a fan. Pretty simple, right? That'll do it for the router section of the hardware. Now what we're going to look into is the hardware associated with the layer 2, which was the data link layer. And what we're going to find there are bridges and switches. All right, it's very important under bridges to come to an understanding. It used to be in the early days of networking that there were separate devices that were made that are specific to the bridging technology. In other words, this is what was offered here, and it wasn't routing as well. But in today's network, so what you're going to find, especially in Cisco environments, is the fact that you have one device, and this is going to be your router. Now, dependent on configuration within the configuration file, you can set this router to operate as a bridge also. So it can have bridge capability within the routing device. Okay, so it's not going to be a separate device. With switches, we are going to have separate devices. And those separate devices are broken up into 2 categories. There's the WAN switches that are used for wide area networking, and there's also the LAN switches for local area networks. These are the 2 that are most common, and within the CCNA, you're going to be familiar with the 1900 and the 2900 series of LAN switches. I've got sample pictures of these devices as well. We're going to start out with a look at the 1900 switches. And as we did before, we're going to look at the front first. Now it's going to be a bit different here because the front has a lot more meaning in a switched environment. Here we're going to see the interfaces associated with that switch. This particular type of 1900 switch is a 1912. It's so named because it has 12, you can count them here, different interfaces that you can plug into or ports. What we're going to see on the left side here are status indicators for the system and then the packets per second. We also see a mode selector. Then we have the ports as I spoke of earlier. Then we have 2 additional ports here. It's the A and the B port rated at 100 megabits. These are all 10 megabits for regular Ethernet. These are fast Ethernet. And what they're used for is uplink ports. In other words, to tie switches to other switches or switches to routers. Now we're going to look at the back side of a 1900. This is where it's a bit more uneventful. We have the power cable receptacle. We have a place for DC input. Remember, this is AC, so this could be DC. A fan, the console that's always going to be there, and an AUI connection. Remember we spoke earlier about the fact that the console and the auxiliary would be there? That's true on routers and in some instances of switches, but on switches a lot of times what you're going to do is just have a console port. And the reason for that is that these switches were originally made by another company that was acquired by Cisco. Let's talk more about this AUI port. It's an Ethernet connection that is available for connectivity if you put a transceiver on here that you can use in your networked environment. I just mentioned the lack of an auxiliary port as one of the differences between this switches and the Cisco routers that are available. I also want to go back and show you that in the numbering of these devices, as you can see here, that's the number 1 through 12 on the ports. Remember with the routers you started at 0. Cisco likes to start its numbering at 0. In any devices that were made originally by Cisco, you will see that. Now if they were acquired devices, you may see, as we do here, where the numbering starts with 1 and proceeds through whatever the end port may be. Moving on to the second switch that I have to show you, we're going to look at the 2900 series. We're going to start with the front again, and what we're going to see is 24 ports available now. This is a 2924, again named for the number of ports. The numbering starts at 1 and goes up to 24. We have the same status lights on this end as well as far as the front end is concerned. Note that we do not have the 2 uplink ports associated here. The reason for that? Every one of these ports is capable of 10 or 100 meg. It switches either automatically or can be programmed by the administrator. Because of that, any of these ports can be used as uplinks, so they don't have to designate 2 at the end of the switch. You'll find that the back of this device is similar to that of the 1900 back, and the fact that it has the power receptacle, a number of fans, and the console connection, and then the DC capability for power as well. We're also going to take a view at the inside of a 2900, and we're going to find that here. And what you're going to find is, again, a motherboard that lays across here, but this time we're going to have obviously a lot more port interfaces, and you see them all lined up here in the beginning for 1 through 24 ports because this is the 2924. Then you have your fans and power supplies as you would within a router as well, and connectivity for the back end. It is very important to note that as we looked at the inside of a 2500 series router and now the inside of a 2900 series switch, that there were no hard drives in either of the devices. The reason that's important is hard drives incorporate moving parts, which means mean time between failure, or how long those devices are going to last, is limited in comparison to a device like this that has no moving parts. Everything is done electrically through the device, and it's going to last a lot longer. That'll do it for our discussion on the layer 2 devices, or the data link layer. Now we're going to concentrate on the physical layer, which is layer 1. There are 2 types of cabling generally associated with the physical layer when we're talking about routers and switches, and those are LAN and WAN type of cabling. Within LAN, we can connect token ring devices, we can connect Ethernet devices. The devices that we're going to show you today are used to connect Ethernet devices. If you recall, when we talked about the 2500s and the 3600 routers, namely the 3600, we saw a number of interfaces there. Some in support of serial connectivity, as we see here for these 4, and others Ethernet connectivity, as we see here. And note that Ethernet is denoted by yellow and serial by blue. They make this as easy as possible. All right, so what we're going to have is the 2 type of Ethernet connectors that are popular, and one here is the AUI connection, and the other here is an RJ45 acceptable interface, which is the RJ48. So we can plug a cable in directly here, or in this case, we would have to plug our network cable into another device to adapt it to this type of connector, and that device is called a transceiver. I have a picture of both to show you now. If we're plugging directly into the router itself, we'll plug the end of our cable, that's this end here, which is known as an RJ45 connector, into that RJ48 receptacle. If we have the AUI connector, remember that interface right here? This is the male portion. You plug this into the router, and on the other side here, it looks like this transceiver, and that's where the RJ48 is, so we can plug our cable into that device. Both of them are used for Ethernet connectivity. Now let me show you the WAN connectors, or the serial connections that will plug into these ports here within our 3600. What you're going to see is a cable that, although both ends look exactly alike, are different, because this is the end for data terminating equipment, and this is data conditioning equipment. You see the initials there. Electrically, they are different, even though the connector seems the same here, but they're used for wide area connections. Of course, there are many other types of WAN connectors or serial connectors. Examples of are VDOT35, DB25, and the list goes on seemingly forever. I just showed you one type of WAN connector. In this nugget, we started out by defining what the CCNA is all about. Then we looked at the benefits associated with getting your CCNA. And then we showed some examples of the hardware that will be involved within this series. All of which was presented to you to make you feel comfortable and get you ready so that we can run through this series and get you your CCNA certification. I hope this has been informative for you, and I'd like to thank you for viewing.